Hello, guys. You are welcome to this live stream section with GMAETS 41. No, I just feel like crying this morning. I woke up and just can't believe myself that the video lesson analysis, all right, and the live stream yesterday, where I try to analyze a particular highly likely exam question. Just some part of the stream was made available on YouTube. The remaining part, which focused on the confirmation or test for anions, could not be uploaded, and I just felt so sad this morning. Really quite tired, even say it reflecting my voice, and supposed to actually be working on titration question on percentage purity this morning before going out for our physical tutorial on campus. But you see, as it is, I've got no choice. I just have to make sure that the later part of that live stream section on salt analysis is made available. You can see it here. Okay, I actually did all the analysis. The question was read from part 1. Okay, and I'm using this opportunity to appeal to you, please. I think one of the students mentioned that the part 2, that they're looking forward to the part 2. And I was just wondering, because I'd already worked on all of this, but all the same, no problem, okay? Thank God for the live this morning, and I'm going to quickly just work on this again, all right? I wouldn't want to just be explaining this on the board, because I want you to follow through what led to these things on the board. I'm going to be fast as much as possible. I just left it so that you would see that, yeah, I actually finished the work, okay? So you're welcome to the class once again, and let me wipe this part. You can see number 4, third portion of solution 1 above. So I'm actually kicking off from where we stopped up, where YouTube, broke up the video. But of course, I really don't think it's the fault of YouTube, because network that yesterday night was just something else. Yeah, network was something else. So it's understandable. All right, let's move on. Let me wipe here. Okay, let me wipe here. Already in the description section, in the description box of this particular live stream that is ongoing now, I have dropped the link to part 1. In that part 1, if you see it, you'll be seeing something like 1 minute, 5 seconds or something like that, but it only showed up to, I think, 39 minutes, 51, or 52 seconds, something like that. So to follow up with the question in terms of what we're actually trying to do, I advise you to visit part 1, okay? Visit part 1 so that you can follow through, because I'll be continuing with that question, moving to the third portion of our solution. But as a quick summary, in the salt analysis, we are given salt X, and then we're asked to dissolve salt X in water. Dissolve it in water, then divide into 4 portions. The first 2 portions, the first portion you have to add sodium hydroxide in drop and in excess. The second portion you have to add aqueous ammonia in drop and in excess. We've analyzed that, which gave us zinc as the cation present in salt Xn. So to the third portion, the examiner said you should add the solution or the reagent, barium chloride, and then follow it up by dilute hydrochloric acid. Yeah, that is what we are told in the third portion to do. Please, as you join the class, help me share this link, okay? I really don't have that time to do that now. Share it to your classmates, to your friends, to our group. If there is any GMAETS 41's student presently connected to this live stream, share the link to our WhatsApp group, please, okay? 100 level WhatsApp group. I'll appreciate that. All right, good morning, dear. Thank you, Wisdom. Thank you for understanding. That guy. Thank you. Let's move on, please. Number 4. Number 4, we have third portion of solution from 1 above. Now, the examiner asks us to add the reagent barium chloride and then follow it up by adding dilute hydrochloric acid. Good. This is what we are asked to do. Now, I actually explained in that part 1, the part that was cut off, all right, due to network challenge. I don't know, because the thing is still showing 1 hour and something. Maybe much later, the upload can be done, but I just can't wait. Let me run this for some that might be needing it before their exams later. And in case the full stuff is not made available, you have this part 2. Now, before we move on into analyzing this, like I said, we are not running the experiment live. So we're trying to use the reagent given to us to predict. Ezian, you're welcome. Good morning. I hope you had a good night rest. We are trying to predict, okay, what likely would be there that the examiner wants us to test for. Now, this is what you should know. This is third portion of that solution from 1 when XN was dissolved in water. This is the third portion. Now, the examiner did not stop in the third portion in that instruction. The examiner went further to also ask us question on the fourth portion. And let me tell you something, that fourth portion, do you know what they asked us to add to the fourth portion? We were asked to add silver trioxonitrate 5 followed by ammonia. This is interesting. Now, I'm going to tell you, let's work on the intelligence of the examiner to an extent. You know, you are meant to carry out this experiment live. It's only when you are checked with time, you can now use this expertise and experience of what standard approach to salt analysis work is all about. You can use that experience based on what I'm explaining so far to predict likely what is there, and then use your theoretical knowledge to fill up. Like I said, we are talking exam as it is, no time, right? Normally, for your examiner to bring this, once you see barium chloride and then followed by dilute hydrochloric acid, here you are now testing for anion. You are now testing for what? Anion. Because in the case of cations, like I said, you use sodium hydroxide and aqueous ammonium majorly. Then when you talk about lead, then you bring in something like potassium iodide or potassium tetrachromate. Once you hear barium chloride, you are testing for this anion, this negative anion, SO3 2- or SO4 2-. Yeah. Which means in your exam, once they tell you add barium chloride, pause and immediately let your brain think towards the direction of any of these two guys. Reason, barium chloride is the major reagent used when testing for the trioxosulfate 4 ion and the tetraoxosulfate 6 ion. Now, there is a possibility here that, okay, this guy might be present, one of them. That is why they ask you to use barium chloride. There is also a possibility that this guy, none of them, is present. Yes. But remember what I said. You're trying to predict. You saw barium chloride. It means you are looking for one of these guys. But the chances are that you could see the positive reaction of this ion, which is, of course, white precipitate will form when you add barium chloride. Are you following, right? And it is also possible that your examiner gave you this to test you in the negative direction. What do I mean by that negative direction? That is to say, none of this ion is actually present there, which in that case, you would say no visible reaction, and the inference would be this guy is absent. But wait a moment. Assuming that there is no time to run this experiment as the case might be, is there a way one can predict this without fully carrying out the experiment based on the way the examiner presented the instruction? 80% to 90% confidence, I can say yes, we can predict it. Like in this case now, since in the fourth portion we were asked to add ammonia, since in the fourth portion we were asked to add silver nitrate and then followed by ammonia, it simply means that likely your examiner knows that these guys, they are not present in that salt XN, that they are not present. Yeah, that they are not present. So he wants you now to carry out this instruction first, and then there will be no positive reaction showing that any of these guys present. So that you can now do your inference, write your inference and say that this SO32 minus and SO42 minus they are absent. Then the fourth portion now, where you are adding silver nitrate and followed by ammonia, will now help you to know actually what is the anion in that salt XN. That is actually one of the major standards in the way that examiner presents your exam questions on this. Remember, I did not say 100%, but to a high probability of 80 to 90%, this is usually the way this thing is presented. Because on a normal, it usually does not happen like that, whereby maybe this guy, this instruction will come first, confirming that this is present. And then the examiner goes further and then giving you another instruction, which will confirm that the other aeon, that reagent in the last instruction is testing, that aeon is not there. They don't usually present the work in that manner. If there is going to be a negative test, that is to say, the aeon you are suspecting is not there, that instruction usually comes before the final instruction that will help you confirm actually the one that is there. So that is the trick. Therefore, I am concluding that the fact that we still have fourth portion, and in the fourth portion we were asked to add silver nitrate and ammonia together are used to confirm chloride aeon, Cl negative. So the fact that we have fourth portion likely means that in this third portion, this guy, we are not going to see it. And if that is the case, since barium chloride is the reagent used for them, we'll come here and say no visible reaction. No visible reaction. Remember why I am going in this direction, assuming that I'm not carrying out the experiment. But please do the experiment as much as possible, except find out that maybe you are choked with time, as the case may be. You can now use this analytical method to predict what likely might be there. So from here, I'm going to write SO32 minus and SO42 minus absent. Absent. Remember what I said. The fact that we have fourth portion, and we are asked to add silver nitrate and ammonia. Silver nitrate and ammonia, they are used to confirm chloride aeon. Since that is the last instruction, the high possibility there is that you are actually confirming the presence of chloride aeon in that salt XN. This one that was given before is just for you to test in the negative direction, saying that this is absent. But please take note, it is still a bit possible for them to actually go the other way around, whereby this instruction will come, yes, and there will be a positive reaction showing that this guy is present, one of them. Are you following, right? Showing that one of them is present. The only thing you want to take note is that if any one of these guys is present, the observation would be white precipitate formed when barium chloride was added. Then the addition of dilute hydrochloric acid, usually in excess, is to find out whether the white precipitate of any of these guys will dissolve or not. Now, if you observe white precipitate form on adding barium chloride, and then on adding dilute hydrochloric acid, the precipitate dissolves, it means that it is SO3 that is present. And usually a gas is given off sulfur 4 oxide SO2. Are you following? So you can say that SO2 gas from SO32 minus confirmed. However, if you add barium chloride and there is a reaction, you see white precipitate. Then on adding dilute hydrochloric acid in excess, the white precipitate did not dissolve. If it did not dissolve, then you know that it is SO42 minus that is present. No gas is given off in that case, okay? But like I said, I'm trying to predict something, so I'm working in that direction, saying that there is no visible reaction when you use barium chloride. Then the last portion, which is the fourth portion. The examiner said you should add fourth portion of solution from one above, plus silver trioxonitrate 5, then plus aqueous ammonia. Good. What should the students know at this point? Silver trioxonitrate 5 and aqueous ammonia are the reagents used to test for the presence of chloride ion. And since this is the last instruction in the question we are analyzing here, most generally, the examiner will take the last instruction to help you confirm the main thing that is there. Yeah, that's what usually happens when questions are presented. For that reason, GMAETS is concluding that in attempting to predict what is here in that salt, XM, we have been able to predict zinc ion. In this case now for the anion, zinc ion is cation. For the anion, what is actually present in that salt XN is chloride ion. That is why the reagent used to confirm chloride ion came last. If this guy had come before this reagent, let's assume this instruction came below, and then this one came upward in the instruction, then it likely means that chloride ion is absent. This will not show any positive reaction. Then for this instruction coming last would likely mean that yes, you are trying to confirm the anion that barium chloride tests for. All right, let me write the observation. When you add silver nitrate and followed by ammonia to a solution, to a salt that contains chloride ion, you are going to see white PPT, white precipitate. Remember, like I said, write your precipitate fully. White precipitate formed on addition or on adding silver trioxonitrate 5. On adding silver trioxonitrate 5. Then when you add aqueous ammonia in excess, when you add aqueous ammonia usually in excess, the PPT dissolved in excess aqueous ammonia. You can also simply write this, the PPT dissolving in aqueous ammonia if you don't want to put this excess. It all depends on the way the instruction is provided. If they use excess for you, fine. You write in excess ammonia. They didn't put excess, you can just say in ammonia. That the PPT dissolved in ammonia. Once you see this, it shows that chloride ion is present. You can also say chloride ion confirmed. Chloride ion confirmed. So this is what you are meant to know about this analysis. Please take note. Instead of using silver nitrate, your examiner could give you lead 2 trioxonitrate 5 instead of using this silver nitrate. So in case you see this, for any test, if they wish to test you on this, and you see lead 2 trioxonitrate 5, it serves the same purpose as silver nitrate. Like this one now, in place of barium chloride, your examiner may decide to give you barium trioxonitrate 5 instead of barium chloride for this one. Are you getting me right? And in place of dilute HCl, your examiner might choose to give you dilute HNO3. So you take note, they will still produce the same effect. Take note. All right. So we are now concluding. But before I conclude, there are 2 other ions I want to talk about quickly because they did not appear in our analysis here. One of them is CO32 minus trioxocarbonate 4 ion. How do you know? How can you predict that, okay, this is what you are looking for? CO32 minus, the reagent used for it is dilute HCl only, dilute hydrochloric acid. So if you are asked to add dilute hydrochloric acid, only that reagent to a given portion, then you should be suspecting that you are looking out for CO3 2-. So in the observation, it is either when you carry out the reaction, you get a positive observation as to what you know theoretically about the behavior of CO3 2- to HCl. It's either you see a positive reaction to it or you see a negative reaction to it. So the question would be, how does CO3 2- salt behave with dilute HCl? So it's going to be maybe a particular portion of the solution, depending on whatever they say there, plus dilute HCl. Now, what is going to be the observation? If this sort of this guy is there, CO3 2-, a brisk effervescence will take place. A brisk effervescence, B-R-I-S-K, effervescence will take place. A colorless, odorless gas was liberated, which turned damp blue litmus paper to red and lime water milky. That guy is actually carbon dioxide. That is what you are going to observe. And usually whenever you are testing for any anion that produces a gas or any cation that produces a gas, generally it's expected for you to test for the nature of that gas. That is where you use litmus paper, okay? So in this case, a colorless, odorless gas that turns damp blue litmus paper to red will be given off. That brisk effervescence, how do you identify it? Have you opened a Coke bottle before? If you open it, you're going to hear shh. That sound is what we call brisk effervescence. So once you are adding dilute HCl to any salt, any solution, and you hear that shh, and some things are coming out as like smoke, right? That's the gas. You know that you are testing for what? CO3 2-. That guy is there. But suppose you add dilute HCl to that sample and there is no brisk effervescence. You didn't hear anything, that sound shh, nothing. It's as if nothing is happening to that solution. It means that CO3 2- is absent. The observation will be no visible reaction. Are you getting me right? No visible reaction. And then you conclude that CO3 2- is absent. So you take note of the key point. Once you are adding only HCl, dilute HCl to any portion, you know that you are expecting CO3 2-. So it is either CO3 2- is there, which will be confirmed by the observation, that brisk effervescence, or it is either CO3 2- is absent, which in that case there will be no visible reaction. You won't hear that brisk effervescent sound. All right, then finally, the cation NH4+. NH4+. Ammonium ion. How do we test for this guy? This guy makes use of sodium hydroxide. If you add aqueous sodium hydroxide to any sort of ammonium, it could be ammonium chloride, NH4Cl. It could be ammonium tetraoxosulfate 6, NH4 in brackets, then subscript 2, then SO4, ammonium tetraoxosulfate 6, right? If you add sodium hydroxide to a salt of ammonium, a gas will be given off. If ammonium is there, this is what is going to happen. Once you add that sodium hydroxide, a colorless gas with characteristic choking smell will be liberated, which turns damp red litmus paper to blue. That gas is actually ammonia. I said that it has a characteristic choking smell. So this guy is quite easy to identify in the lab, because if the ammonia is coming out, you're going to perceive it. It's very choking, irritating odor. Are you following, right? And then you will now know that the cation there is NH4+. Then what will now be the inference? The inference is going to be the gas is alkaline. The gas is alkaline because it's only alkaline gas that turns damp red litmus paper to blue, while acidic gas turns blue litmus paper to red. So in this case, the gas given off is an alkaline gas, and the only alkaline gas we have, take note, the only alkaline gas we have, your examiner can ask you that question as a follow-up question. Sometimes if you're testing for NH4 plus salt, the only alkaline gas we have is ammonia, NH3 gas. So the inference in that case is going to be the gas is alkaline. NH3, that is ammonia gas, from NH4 plus, confirmed. That is how you present the inference there. Thank you very much, Chinedu Martins, and thank you for being a channel member. Thank you for your support. All right, thank you for your support. God bless you so much. I really appreciate what you sent across. Okay, thank you so much. Remember to become a channel member, dear friends, and just click on the join tab, and then you select any of the package available. Support GMAETS 41 with whatever is convenient for you. I would gratefully appreciate. All right, now let us conclude this analysis, please. Let's conclude. We are done with all the 4 portions, and you see the way using the reagents given, as well as the way the instruction was provided. You see the way I could predict, are you following, right, what the cations and anions in this salt XN really are. After that, in the instruction, this was what the examiner said we should do. The examiner said we should identify the salt and then give the IUPAC name. Now, how do we answer that question? How do you identify the salt that you tested for during your salt analysis? It's simple. Just go to your inference. Ask yourself, what did I confirm in the process? Now, in part 1 of this analysis, we confirmed zinc. In fact, I recall that we had zinc ion, confirmed. So I am going to have something like this. You would write this, in your solution book just below this analysis. So let me underline this because we are done with the main test. We confirmed zinc, so we have zinc 2 plus. Are you following, right? And we confirmed chloride ion. So these 2 guys are the ions present in that salt XN. If they combine, writing correct chemical formula of a compound using the knowledge of valency, this is their valency. The valencies will be interchanged. These 2 will go to chlorine down here and become atomicity of chlorine. This is -1, the valency of chlorine. It will come to this zinc down here and become the atomicity of zinc. So that the product we now get would be ZnCl2. Are you following, right? Cl2. I'm going to put solid because that salt XN is actually a solid. It was given solid form before you dissolve in the first instruction or method. So I can now conclude that XN is ZnCl2. And what is the IUPAC name? What is the IUPAC name? Let me write it here. IUPAC name of that salt XN is zinc chloride. Zinc chloride. That's good. So that is that about this analysis. And I think with this particular guy, we've been able to deal with all the cations and, of course, all the anions that you will likely be tested. I don't see them testing you on NO3 minus, that brown ring test. Maybe you did it in the laboratory, but why I'm worried that you might not be tested on it is still for safety purpose. I'm not seeing your examiner really taking that risk, exposing a student to concentrated solutions. Because in that guy, you use concentrated tetrosulfate 6. Before somebody will shout from somewhere, hey, help, So I really don't see that coming. But if at all, for any reason it appears, because you can work on that based on what you've done in the lab. But I'm not going to bother myself on this. I've also told you too, I don't see the possibility of aluminum being tested. Reason, that one is a cation, because you also use a concentrated acid to confirm aluminum. I think concentrated hydrochloric acid. No one would really want to risk that all right, for students to test with them. So basically, the ions that you are likely to meet in your exam in your Chem 107 chemistry practical, we've analyzed all of them as it is. For the other cations, which are colored ions, I don't usually talk much about them because they are very easy to confirm. I've talked about these a bit before. Copper 2 ion, the salt is usually blue. If you add sodium hydroxide to it, or you add ammonia to it, you're going to see blue precipitate. Now the thing is, if you now add sodium hydroxide in excess, if it is copper ion, you see that blue precipitate, the blue precipitate will not dissolve. Are you following? So you say the blue precipitate was insoluble in excess sodium hydroxide. But if it is aqueous ammonia, you add it to a salt and you see blue color, you know that it is copper that is there. You say that blue precipitate was formed in drops of ammonia. Then when you now add that aqueous ammonia in excess, that blue precipitate will dissolve in it. So you say that the blue precipitate dissolved in excess ammonia to give a deep blue solution. Then you now infer copper 2 ion confirmed. Ion 2 ion is green. If you add sodium hydroxide or you add ammonia, you are going to see green precipitate. And when you add either sodium hydroxide or ammonia in excess, the green precipitate will not dissolve. Then you confirm ion 2 ion. Say it is present. Yeah, it is present there. Because the confirmatory reagent for ion 2 ion and ion 3 ion is not actually ammonia anyway. We use the hexacyanoferrate 3 complexes to confirm their presence. But you won't be given that reagent, so working with sodium hydroxide and aqueous ammonia. Then finally, for ion 3 ion, that guy is brown. So once you add either sodium hydroxide or you add ammonia to a salt that contains ion 3 ion, how would you know that ion 3 ion is there? You will see a brown precipitate formed. Whether you add sodium hydroxide in excess or you add sodium hydroxide in excess or you add ammonia in excess, that brown precipitate will not dissolve. It will not dissolve, it will remain. And once that happens, you write ion 3, that is Fe3 plus present. Once again, I wish you guys all the best. Thank you for connecting to this class this morning. Miracle Chibo, can you write in the case of CO3 2- that the gas is acidic? Yes, you are meant to write it. So if I did not say it when I was explaining that of CO3 2-, please apologies, okay? But I guess I made a reference when I was talking about alkaline gas. So in the case of CO3 2-, in the inference, you are meant to write the gas is acidic. Then CO2 gas from CO3 2- confirmed. That's how you present that. All right, dear friends, I will be leaving you now. At least I've presented the second copy of this. By God's grace, later this evening, I'll be working on question on percentage purity. That's actually what I intended doing this morning before I found out that the later part of yesterday's stream was not available, so I had to work on it. All right. I wish you all the best, dear friend, in your exam. Remember, like I said, be confident. Your examiners are not going to space to bring out your questions. They are all based on what you did in the laboratory. Whether you had full idea of what you did in the laboratory or not, if you have been following the GMAETS 41's classes, definitely you've gotten as high as 98% to 99% of the knowledge you need to beat up this. And remember, like I've always said, your examiners, they have nowhere to dribble you to if you've always been following up with the GMAETS 41's classes. Please, my dear friends, go into that examination hall and get the GMAETS 41, that A that you deserve. A splash. That's the language, the GMAETS 41. Understand? And remember, your first class is on the way. You can do it. Yes, I have this confidence in you. You can do it. Believe in yourself. Go in there, sit for exam today, and come out joyfully. I'll be seeing you later. I wish you all the best.